Hey math kids, today we're going to talk about second and higher derivatives, and really all you do is keep taking the derivative of the derivative. So f double prime means find the second derivative of f of x, which is x cosine x plus 1 over x. Alright, so first we need to find the first derivative, which this is going to be a product rule. And then this is pretty straightforward. So I'm going to do this product rule first. So I'm going to call this A, call this B. A prime is 1, B prime is equal to negative sine x. So we just take the first times the derivative of the second plus the second times the derivative of the first. Once again, this is just this thing. And then if we do the derivative of 1 over x, we're going to have to interpret that as x to the negative 1. So we bring the negative down in front, and then we're left with x raised to the negative 2. Okay. Now let's do a little bit of simplification, and we'll write it. So this first part is going to be negative x sine x. This is just going to be cosine x. And this is going to be minus x to the negative 2. So that's the first derivative. So if we want the second derivative, we just take the derivative of that. Alright, this is another product rule. And so if my a is negative x, my a prime will be negative 1. My b prime is going to be cosine x. And if I write this out, I'm going to do my first one, which is negative x, times derivative of the second one, which is cosine x, plus the second one times the derivative of the first one. Okay, once again, that was just the derivative of this. And the derivative of this is negative sine x. And the derivative of this is going to be positive 2x to the negative 3. Doing some simplification, we get negative x cosine x minus sine x minus sine x plus 2 over x cubed, and we can combine those, and so our final is negative x cosine x minus 2 sine x plus 2 over x cubed. And looks good. What we're going to do now is f of x equals cosine 2x. And we need to show that f to the 3, or triple prime, of pi eighths is equal to 4 root 2. So we just need to prove this. So we first just need to find the third derivative before we even worry about this. Okay, so if we take the first derivative, cosine goes to negative sine, but then we need to multiply by the derivative of the inside, so we get a 2 right there. Now if we do second derivative, I'm just going to focus on, so we bring down the constant, and then we do sine goes to just cosine, and then we times by 2 because of the derivative of the inside, and so we get negative 4 cosine 2x. And if we're going to the third derivative, bring down that constant, cosine goes to negative sine, and then multiply by the derivative of the inside. These negatives will cancel. 2 times 4 is 8. And so our third derivative is this. Now we want to prove when we plug in pi eighths to this that we end up with this answer. Okay, 2 times pi eighths is going to give us pi fourths. If we remember our unit circle, pi fourths is square root of 2 over 2, square root of 2 over 2. I did not write very well. Sine is the y value, and so we get 8 times square root of 2 over 2. And when we do that, we get 8 square root of 2 over 2, which simplifies to 4 square root of 2, which is what we wanted to prove. If you need additional help, please come to Math Lab. Until then, calculator.